Hello, good morning, good afternoon, good evening all. Welcome to Sorup IT Learning Solutions. Now in this particular series, we are continuing to learn installing, configuring and managing VMware Hypervisor version 8.0 infrastructure. Now in this particular module, we will learn following topics. Now this is the new module. We have up to now we have covered 14 modules. So this is the 13 modules. So this is the 14th module what we are going to cover over here. So in the upcoming current video, we will cover following topics. So understanding the practical and theoretical concepts of virtual bridge adapter, that is your VMware Workstation. That means we will try to understand what is virtual bridge adapter, which is one of the component of VMware Workstation. Second component is distributed switch, which is a component of vSphere Infra. Third is virtual switch, again component of vSphere Infra. Then VMKernel adapter, again vSphere Infra. Fifth component we will try to understand port group, which is again through vSphere Infra. And the sixth component will be uplink. What is uplink? Through vSphere Infra. Now why we need to understand all those terms? Because we are actually practically using all those components for this particular module or for next 3-4 modules. Now what is the objective of this particular module? Now the objective of this particular module or the next 3-4 modules is providing internet connectivity through VCSA GUI console or through virtual distribution switch to ESX hosts and Windows 11 CL nested VM. Okay, now in our lab setup we have created our ESX host, we have created our nested virtual machine, we have tested our vMotion also, HA also in the previous parts. Now the main objective of this particular module and next 3-4 modules is to give the internet connectivity to our Windows 11 CL, which is a nested VM. Okay, now what is nested VM, how we have created it, you can see in the previous videos also, or the next 5-10 minutes I will be explaining you the same thing. Okay, so for this particular module, we will be providing internet connectivity through VCSA GUI console. Next module, in the next few videos or next few modules, we will also cover the following topics practically. So in this particular module, we are giving the internet connectivity to Windows 11 CL through VCSA GUI console. Same thing we are doing, providing internet connectivity through VCSA power CLI command. That means one is a GUI option and one is your command line option. Again, objective is same, to give the internet connectivity to ESX host and Windows 11 CL VM, but this is through VCSA GUI console. One particular video, then next video we will cover through VCSA power CLI commands. Okay, second option, objective is same, option second. Option third, again objective is same, providing internet connectivity, but the option is through Windows 2022 NAT provision to ESX host and Windows 11 CL nested VM. Okay, so this is the third option we can try. And the last option or the first option is same objective, providing internet connectivity through Linux proxy, a dedicated new virtual machine which can be used as a router gateway or as a internet proxy between your ESX host Windows 11 CL and your physical host. So the objective is same for all 4 options, providing internet connectivity to ESX host, but the ways are different. First way, VCSA GUI console. Second way, VCSA power CLI commands. Third way is Windows 2022 DC NAT provision, and fourth way, your Linux proxy. So all 4 options we will see one by one, but in a different dedicated videos or different dedicated video parts. Okay, I hope I am clear up to this point. Now in this particular module we will see some practical terms. What are those practical terms? Like I said, these are the 6 terms we need to understand before actually we are moving to the practical steps. Okay, so let's move on to the theoretical concepts first. So let's start. Now the first concept or the first component we need to understand over here is what is virtual bridge adapter, and that is a component of your VMware workstation. So a virtual network adapter that directly bridges a VM's traffic to the host's physical NIC, allowing the VM to appear as a separate device on a same physical LAN. Okay, so what does it actually means? So I'm just coming back here, just opening my VMware workstation console so that you guys can have a better idea. Now here, if I'm going to edit an virtual network adapter, you can see there is a one VM net. Okay, so if I'm clicking on change settings, so VM net type is what? Bridged. Okay, here you can select the bridge one, and then you can select, you need to bridge to which NIC, which physical NIC. So this physical machine is having a physical NIC of Realtek Gaming 2. So this VMnet 0 is a bridge adapter between my virtual adapter of VMware workstation and my physical NIC of my host. So whichever connectivity my physical NIC will be having, same connectivity will flow down to my bridge network adapter. Okay, so same thing, it is explained over here. A virtual network adapter that directly bridges a VM's traffic to the host physical NIC, allowing the VM to appear as a separate device on a same physical LAN. Okay, so as of now, just understand it in a theoretical concept. Next module, when we start the practical steps, you will get more feel of it. Okay, so this is the first component. Second component is distributed switch in vSphere infrastructure. So what is distributed switch? A centrally managed virtual switch, that is distributed switch, controlled by vCenter that spans multiple ESX hosts, providing uniform network configuration and management across the cluster. So think about a physical switch. What it does, it is connecting multiple physical machines to a common network subnet, so that all the machines will be on a same network. Same thing, this is a distributed switch through vSphere, through virtual infra, that can be connected to multiple ESXi hosts, so that ESXi host can be communicating with each other on a same network subnet. Same thing, but a virtual switch. Next is, what is virtual switch? So distributed switch can be applied on vCenter level, and virtual switch can be applied on a ESXi host level. Okay, so a software based layer 2 switch inside an ESXi host that connects VMs to each other and to physical networks through attached uplines. Now the difference between distributed switch and virtual switch is a bit confusing for the beginners. Distributed switch means VCSA level type of a switch. What is VCSA? VCSA can manage multiple ESXi hosts. So whichever component I am creating on VCSA level, that can be applied on multiple ESXi hosts. But if we are not using VCSA, let's say if you are using individual ESXi host, then this virtual switch is an individual level of a switch. Both are switches, but this is more like an centralized switch which can be applied on multiple hosts, and this is like an individual switch. Okay, so distributed switch is on VCSA level and virtual switch is on a local ESXi individual level. Okay, so don't worry about it. We will see how those components are working actually practically once we are getting into the practical mode. Now fourth component we need to understand is VMKernel adapter. Okay, so a special network interface used by ESXi host itself for management vMotion, iSCSI, NFS and other host level services. Now VMKernel adapter is something which can be used for connecting your virtual machines which are being created through ESXi host. It's a virtual machine kernel adapter. It's a virtual adapter. Think about it as a physical NIC. Unless you are having a physical NIC, you cannot connect any machine to a network. Same thing, unless you are having a VM kernel adapter, you cannot connect your VM to any kind of a network. Okay, so VM kernel adapter, again it is ESXi level, not on VCSA level. So each ESXi can have multiple VM kernel adapters, and those VM kernel adapters can be used for VMs which are hosted by that ESXi host. Okay, so same thing, just like a switch, we need to create a VM kernel adapter also to get our VM connected to VM kernel adapter first. Then that VM kernel adapter will further get connected to virtual distribution switch. Okay, same thing, same like your physical network fundamentals. Okay, next is port group. Now port group is something like a logical network label on a virtual switch or VDS that defines a specific network segment and policy set to which virtual machines NICs or VM kernel NICs are connected. Now think like a port group is like a network segment. Suppose my one virtual machine is connected to 192.168.1.x range, and another machine is connected to 10.1.1.x range. So both VMs are actually working on different segments. So I need to create two different port groups which can have those network segments. So a port group is like, let's say, a virtual logical unit or virtual geographical unit. Let's say a Mumbai office is having 192.168 range, Delhi office is having 10.1.1. range. Okay, so both uh, locations are having different switches or different network segments. Same thing in a virtual infrastructure, port group is a logical segment for different network subnets. What is port group, why it is required, how we are going to create, all those things will get clear once we are getting into practical modes. So as of now, just understand those terms, and on a practical basis we will see all those terms in more detail once we are getting into the next module. And the last component of course is uplink. So this is the most important one, a physical network adapter VMNIC on an ESXi host that connects a virtual switch or a distributed switch to the external physical network. Now suppose I have created VM kernel adapter also, virtual switch also, port group also, everything I have created, but unless I am connecting it to the uplink or I am creating an uplink to connect it to the external network, I will not get the external network connectivity. For us, for this particular model, our external network connectivity is internet, right? So we need to create an uplink between our VM kernel adapter and our virtual switch, so that that virtual switch can further communicate with my router, and then it will get the internet connectivity, and invariably my nested VM Windows 11 CL VM will get internet connectivity. Okay, so unless I'm creating one uplink between my nested VM and my router, physical ISP router, I will not get the internet connectivity. Okay, as simple as that. Again, if you are too confused with those all those network terms or theoretical terms, don't worry, we will clear all those concepts once we are getting into practical mode. I'm again and again repeating those things, but I want to give you a brief idea about what we are doing, which components we are actually working. That's why I've just given you this all particular theoretical concepts clearance before we are diving into the practical mode. Okay, so now coming to the diagram part. Now since this particular diagram I have created to make you more understand what we are actually doing in the upcoming module, how we are going to give the internet connectivity to our nested VM Windows 11 CL. At the first sight this diagram might look a very complicated or a glitchy one, but don't worry, I will explain each and every part in detail. Okay, so starting from the left top corner, so this is my internet connectivity. Okay, now this internet connectivity is coming through my ISP broadband provider. Okay, so this red line is my internet connectivity. You can see over here, red line, internet connectivity. It is coming to my home router or office router. Okay, and this router is now having internet connectivity. Now this router is working for two purposes. One is your routing gateway between your internet and your home or office machine, and second thing, it is also working as a DHCP server. So it is having both functionalities. Okay, once internet is connected to router, internet direct public IP, it will not give to my physical machine for the security purpose. It will give a local DHCP IP. Now what is 192.168.1.1? It is a local IP of my router itself. Okay, so my router itself will be having one local IP, 192.168.1.1. Of course it will be having one public IP also, but that is not disclosable to my rest of the machines, not even to my host machine. Okay, but local IP is 192.168.1.1 plus DHCP. So it will start distributing the DHCP IPs to rest of my machine. So every machine will get local IP. So once it is having internet connectivity, next thing is it is connected to my physical NIC of my office system or my home system. Okay, this is my physical machine. Okay, Windows 2022 base physical workstation, and it is having a physical NIC, of course, which is connected to my router, RJ45 connector and all, physical NIC. Once this is connected, it will give, this router will give a DHCP IP to this workstation. So this is 192.168.1.34. This is a DHCP IP. It can be static also, but for the better purpose, if router is already giving you a DHCP range and everything, DNS and everything, why to give the manual configuration? But it depends on your preference. So 192.168.1.34 can be a static IP also, can be a DHCP IP also. Once that is done, IP assignment is done, this machine, the physical machine, don't think about all those ones, I will explain. So this physical machine will be having internet connectivity. Okay, I hope I'm clear up to this point. Internet, your local broadband ISP router, physical NIC connectivity, and then the network internet connectivity to my physical machine. Okay, this is one part completed. Next part is, now this physical machine, I have installed a base OS as Windows 2022 server. On top of that, I have installed VMware Workstation. Okay, so VMware Workstation is an application based virtualization software. All we know about that. Okay, through that VMware Workstation, I have created three different VMs: Windows 2022 DC, ESX01 and ESX02. All those are VMs. Now a main difference over here is these are type 2 VMs. Okay, what is type 1 VM? If I am installing the virtual machine directly through ESXi, which is directly installed on my physical machine, which can be, but let's say it is directly installed on my physical machine, and through that I have created those VMs, then those are type 1 VMs. But I have added one more layer over here. I have installed base OS, then application layer, and then that application layer is having VMware Workstation. Through VMware Workstation, I have created those three VMs. That's why these three VMs are type 2 VMs. You can see over here this particular square line or square border. You can see VMware Workstation type 2 VM layer. Okay, this brown one. So all those three VMs are type 2 virtual machines because it has been created through VMware Workstation. Okay, now I have created one VM0 virtual bridge adapter through my VMware Workstation, and I have added that VM0 virtual bridge adapter to all three VMs 1, 2, 3. Okay, and I have given IPs also 192.168.1.25, 1.7 and 1.16. Why same range? Because my internet is also having a same range ISP router. Okay, so I have given, now these IPs can be DHCP also, can be static also, because router is already distributing DHCP IPs, so these machines will automatically get those IPs. How we are getting the connectivity between router and those three VMs? Because those three VMs are connected to VM0, and this VM0 is directly mapped to my physical NIC of my physical machine, and that physical NIC is further mapped or directly connected to my router. So the internet connectivity goes like this: physical router, first is internet, then physical router, then physical NIC, and this physical NIC is mapped to my VM0. So invariably it is passing the internet traffic to my VM0, and that VM0 is further passing that internet traffic to my three virtual machines. So all three virtual machines will get internet connectivity. It's a straightforward procedure that Windows 2022 DC VM will get internet connectivity, but a bit complicated for ESX host. But don't worry, we will see it practically how to do that. Okay, I hope I'm clear. Now, still, once you are adding your VM0 to those two machines, still DC directly will get your internet connectivity. Okay, but for ESX host we need to create one more layer of network interface cards, that is VMKernel adapter. So I have just marked it over here. So we need to create one virtual kernel adapter over here, one for ESX host 01 and one for ESX host 02. So two different virtual kernel adapters, and those virtual machines kernel adapters will have their own NIC. Okay, and those NICs will have the IPs 192.168.1.7, 1.16. Your VM0, we cannot give a direct IP uh, through ESXi host. You can give the direct IP through Windows 2022 DC, but for ESXi host, we need to create one VMK, means your virtual machine kernel adapter. Okay, why do we require that? Why do extra VMKs over here? Because these extra VMKs will further connect to my virtual distribution switch. Over here you can see the green line, both VMKs are connected to VDS. Now why should we do that? Because this VDS will further responsible to give the network or internet connectivity to my nested VM. So it's a bit a complicated procedure. We need to create a VDS also, we need to create a port group also, we need to create a virtual machine kernel adapter also. Then only we will get the internet connectivity on Windows 11 CL nested VM. Again I am telling you, if this is too confusing, don't worry about it. Reverse this video, listen to this explanation again. Still if you are not getting, no problem. You will get the full feel of it, how each component is working, how your VMware bridge connectivity is working, how your VMK, that means virtual machine kernel adapter is working, how the VDS is working, virtual distribution switch, how the port group is working, how the uplink is working, everything we will see practically. Okay, so this is how the VMK will pass on the internet traffic again through your nested VMs. Okay, and once this particular Windows 11 CL will have a network connectivity, it will have a DHCP IP also from router. So you can give a static IP also, but DHCP is fine for nested VM because it's a client machine. For servers, I have prepared to do the static IPs, but for client, DHCP is okay. Anyways, it is distributing the DHCP service or IPs. Why not to use it? So I'm using it over here. So this can be any IP. Let's say next reboot it can be 48. Next reboot it can be again 43. Next reboot it can be 15. Because it's a DHCP IP free range, whatever IP is available, my router will assign that one. But the whole particular purpose of this diagram is to understand how the internet connectivity is flowing from this point up to this point. Okay, all those components, the complicated components are coming in between, but don't worry, we will see practically how to do it, and not through only one procedure or one way, but 4 different ways. Okay, one is your VCSA GUI, second is VCSA CLI, then NAT, and then your Linux proxy also. Okay, so don't worry about it. Okay, so this is how I have just created a simple diagram. It might not be simple for you, but as per best of my understanding, I have created this diagram just to make you guys understand what we are actually doing in the upcoming module. Again, I'm telling you, my total motive is to make you understand the things theoretically, not the practically. Practically, we anything we can do it by clicking next, but we need to understand what we are actually doing. That's why all those stuff, theoretical concepts, are equally or even more important than the practical steps. Okay, so this is the practical thing we are going to cover in the next module. Before that, I wanted to cover those practical sorry, not the practical, theoretical concepts. That's why this module is there. Okay, so this module ends over here. In the next module, we will actually see how to practically implement all those things. Okay, till then, goodbye.